Today's lesson is on graphic representation. Media, businesses, and other groups are often guilty of taking data and displaying it in such a way so that it tells the story that they want it to tell. So the basic idea is here, you can take the same set of numbers and tell 2, 3, or 4 different stories with it if you want to try and spin it in a certain way. We're going to look at a couple common ways of manipulating data. And this stuff is found in newspapers, magazines, on TV shows, on websites, everywhere where people want to say certain things. And they want to use numbers to help convey that information. So here's an example. Shaylin surveys students about their favorite fast food restaurants. She presents her findings with the bar graph below. We have McDonald's, A&W, and KFC. Let's look at this graph. I want you to take a look at it and see if you can determine why the graph is misleading. The graph is misleading because the vertical numbers start at 25. They should start at 0. What does that do? Well, it makes people who go to McDonald's look like there's way more people that go to McDonald's than go to KFC. And like everybody goes to McDonald's compared to the few people that go to A&W. But if you look at McDonald's is somewhere between 45 and 50. And A&W is somewhere between 25 and 30. Which means that this bar should be more than half as big as this bar. What? But it doesn't look like it. So the numbers have been manipulated. So let's go ahead and redraw the graph without bias. So we could say that McDonald's looks like it's, I don't know, let's say 48. A&W looks like it's what, maybe 27. And KFC looks like it's 35. So let's go ahead and put those numbers down here. If we're going up to 48, we have to go to 50. And there's 3, 4, 5, 6, 7, 8, 9, 10 grid squares, which means that we can go from 0 to 50. But if we have 10 grid squares and we have to go up to 50, that means that every grid square has to be 5. So every 2 grid squares is 10, 20, 30, 40. So these numbers represent the number of people. And for the restaurants, it really doesn't matter. We've got 10 grid squares, and we should do space between each one. So let's go ahead and do that. So McDonald's is about 48, we said. So we are going to go ahead and make some bars here. I'm going to go ahead and make these bars red. And let's go ahead and go to 48, hey? So let's say they go like this. And 48 would go up to about here. And the only thing I'm going to do is I'm going to make it so that this is a little bit transparent. Okay, that's exactly what we need. That is McDonald's. Now we'll go ahead and we'll do A&W, which we said was about 27. So 27 would probably go up to about right there. And then the last one was KFC, and that was 35. So that's going to go up to there. And again, we'll just take that down a touch. There we go. So we would label this as McDonald's, A and W, and KFC. And these all represent restaurants. I've mentioned this before when we've done bar graphs, but I'll mention it again. Make sure your bars are separated for bar graphs. Make sure they're drawn with a ruler. You do not have to shade your bars, but you do need to draw your bars with a ruler. They should look like straight lines. If they don't look like straight lines, you will probably lose at least a partial mark. So please be careful with that. Also, the other thing that's important is that your scale has to be consistent. And yes, it has to start at 0. Every grid square is 5. That works. And you need to label what those numbers mean. They're the number of people. These are restaurants, and they are McDonald's, A&W, and KFC. There's our graph without bias. So when you look at this graph, what do we see? Well, we certainly see that McDonald's is the most popular place to go. But it's not way bigger than A&W. Now, it's definitely bigger than A&W. There's no doubt about that. But if we went up here to the first graph, we would see that it looks like it's huge compared to A&W, and that's just not the case. It also looks like it's, I don't know, like over twice the size of KFC. And we see that if we look at an unbiased graph, we see that the height of the KFC part of the bar graph is almost as big as McDonald's. So that's the big difference when we're looking at a graph that has no bias. Now, let's go on and do the next example. A hockey player is negotiating their contract and states that they score goals at a very consistent rate. They use this graph to support their case. Now, first of all, let's look at this. Very consistent rate. What does it mean to be consistent at something? When you are consistent at something, that means that the numbers are all fairly equal. Okay? So if the numbers are all pretty much the same, then they would be consistent. So if we look at this graph here, we see that the highest it is right here. And the lowest it is right here. And so really, we see that the numbers they all fall within a fairly small range. So if they're all fairly close together, that would say that, yeah, those numbers are pretty close, and therefore the goal scorer is pretty consistent with his or her output. So let's go ahead and figure out why this graph is misleading. Well, here we see that, well, the graph starts at 0. So that's not a problem. Not at all. So where's the problem? Well, the problem is that the highest number of goals the goal scorer scores is, what, 27, 28? And the graph goes all the way up to 60. Well, if the highest is like 27, you could probably go up to 30. So the top number ends at 60, and it should end at about 30. So let's redraw the graph without bias. So let's estimate what these numbers are going to be. And we might be a little bit off, but that's okay. I would say that this one is 22. Here, you're probably looking at 18. Then we're looking at about 27. Down here, it looks like 15. And up here, let's say 24. So I'm going to just jot those numbers down here so we have them. 22, 18, 27, 15, and 24. And they go from 16 all the way to 20. I'm just putting them there so I can just draw the graph without having to constantly flip between what I have up top and what I have on the bottom here. So we have 16 to 20. So, okay, so first of all, we'll set up our horizontal axis. So we'll say this is our year. And we'll say that this right here would be, let's say, 20. We'll say this would be 20, let's say right here. This is 16. This is 17. This is 18, this is 19, and this is 20. Okay? And as far as the number of goals go, we do need to start at 0. And it goes up to 30 as a max, let's say. So let's make this 30 right here. If we go up to 30, it means that every grid square is worth 3. So if every grid square is 3, then that means that this would be 6, 2 would be 6, 4 would be 12, 18, 24, and these represent goals scored. So for 2016, that's 22. That would be right here. For 2017, it'd be 18, right there. 2018 would be 27, right up here. 2019 would drop us down to 15, so that's right here. And 2020, we go back up to 24, and that's right there. And now I can go ahead and just erase those numbers that were there just to give me a little bit of guidance. We do need to use a ruler or some kind of straight edge to join these points. Doesn't matter which one you use. Let's try, okay, let's go ahead and there we go. And there we go. And there we go. So we can now see our line graph. Now when we look at this line graph and we compare it to our other line graph, we can definitely see a big difference. So let me go ahead and take this line graph and bring it downstairs. Just so we could kind of see the, are these really the same graph? And they are. And that's the crazy thing. Like if we look at this first one, it looks like they're all kind of around the same. But if we look at this one here, the differences between each year look much bigger. And of course, we can definitely see why the hockey player likes this graph here. Because this graph here paints the hockey player as being a very consistent player, and that's the point that he or she is trying to make. Yet on the graph on the left, we can see that there's fairly significant differences between the number of goals. So again, we can use graphs like this one to minimize big differences between numbers. And if we look at the first example we did on fast food, we can use them to make the differences look massive when in fact they're quite small.